Good morning, all of the SIP committee. My name is Buskon Kaiporn.
My name is Phim Arulrattanadilok.
My name is Supavit Sukputanan.
Today, we want to talk about our project, large-scale one-dimensional compression test on the time-dependent behavior of rock-fill material. The content of our presentation will cover 9 topics.
As we know, the rock-fill material is a typical corrosion-less coarse-grained soil, and it is well known for dam construction because it has several advantages such as be able to use the local material, ability to absorb the earthquake energy, and lowest cost for dam construction. For the topic of concrete face rock-fill dam or CFRD, it is a rock-fill dam which have the concrete slab on the surface, which acting with the water storage. And this picture shows the component, the CFRD dams, which have the three zones, the concrete face protection, concrete face supporting, and the rock fill zone. And this kind of dam usually have the problem of water leakage caused by the settlement of zone 3.
This figure shows the commonly settlement stage of soil, which describes the relationship between the formation and time on log scale, consists of T stage. In our project, we consider at secondary compression stage, which show the creep deformation. Creep defined as time-dependent deformation under constant effective stress. Anyway, the behavior of rockfill material that we use in our project different from commonly soil by only half the stage of initial and secondary compression. This picture shows the example of face slab concrete crack, in which the effect of creep is the one factor that be a cause of cracking. For objectives, the first one to study the behavior of rockfill material under conditions. The second one study the influence of water and gradation on creep of rockfill material. Scope that used in our project. The rockfill material is limestone rockfill from Kanchanaburi mine. We used three different gradations with two conditions of dry and wet. The last one performed tests by using a large modified odometer. Expected outcomes. The first one be able to evaluate the influence of rockfill gradation on rockfill behavior. The second one be able to quantify the effect of water on creep of rockfill material.
According to the objective and expected outcome, we design the three gradation curves between diameter of the rock-fill material and the percent passing, and that curve are in range of suitable gradation to model the specimen. At the same percent passing, gradation 1 has the largest particle size and gradation 3 has the smallest particle size. In our testing, we decided to use the density of specimen at 2 tons per cubic meters, and in each gradation, we have to use the sample about 122 kilograms per mole. From the objective that we want to know, the water will influence to the duration of keep or not, so we decide the test into conditions that are the dry and wet condition. The apparatus in this testing consists of the large modified odometer, modified photorammer, laboratory sieve, automatic data collecting to collect the load, wooden plate, data logger, and the linear variable differential transformer or LVDT to measure the specimen in this testing.
Next, the procedure in testing. The rock sample is saved by using laboratory sieve, which consists of 6 types of sieve. After the rock sample is wet and dry, weigh the rock by using the percent passing of rock in each type. The rock sample in each type will mix and divide into 3 equivalents. Put the first portion of the rock sample into the mold and cover with the compaction wooden plate. But it helps to decrease the fracture of the rock while compact. Compact the rock sample for 26 low for 5 rounds to reach the fixed density by using a modified Proctor-Lammer and repeat the same step for second and third layer. After compact for all 3 layers, put the mold under the compression machine and cover the top of the mold with the lid for expand the loading area. Then place TLVDT on the lid or set LVDT to have 120 degrees apart from each other and have equal distance from the center of the lid. Start the test by put the manual hydraulic pump to insert the load of 50 kN and stay the same load for 1 day. Then increase the load every day to 125, 250, and 450 kN. While testing, the automatic data collecting device will use to collect the load that apply to the sample, and LVDT will use with the data logger to collect the settlement of the sample. After done for testing, bring the log sample out of the mold and perform sieve analysis to check the crushability of the rock sample.
After the experiment, we could collect the raw data of load and the deformation of the specimen. Then we bring the data to plot the relationship between state time, stain time, and state stain to observe the behavior of the rock fill material during the keep. This three pictures show the relationship between state and time in each gradation. By each step is the increasing of the load that we applied at 50, 125, 250, and 450 kilonewtons. And according to these three graphs, it shows that we can maintain the load be a constant for 8 hours per load. These three pictures show the relationship between state and time in each gradation. It is similar to state and time relationship that state will increase when the time is increased too. By each step of the constant loading, the stain will increase slowly before the changing of the load. And these three pictures show the relationship between state and time in each gradation. It shows that when the load is increased, the deformation will be increased too. However, when we maintain the load in the constant value, the deformation will still increase in the slowly rate.
This slide shows the relationship between deformation and time of each gradation. The time increasing corresponding to long-term deformation with equivalent the creep. It shows that the load of 450 kN have the largest deformation than another load, and gradation 1 have the higher deformation which is about 20 mm, while gradation 2 and gradation 3 is 9 and 3 mm respectively. We consider the time interval after 60 minutes to find the slope between deformation and time because we avoid some deformation from distribute of particles. The slope of the graph represents the long-term compressibility index, which relates with the equation. We find the slope of the graph by using origin for program of our gradation. The table shows the slope value of our gradation. This slide shows the relationship between stress and long-term compressibility index. By the gradation 1 and gradation 3 have the similarly trained, but in gradation 2, it has some error at the vertical stress of 1.4 and 2.8 MPa. This graph shows that the gradation influences the cliff of the rock fill material.
All of three graphs show the comparison of percent passing between before and after testing. Notice that the result of percentage passing after test performed or gradations slightly outnumber before testing. Because of rising percentage passings occur from compaction and cracking of rockfill material simultaneously when a load is applied. In part of conclusion, the behavior of rockfill under creep conditions can be determined from deformation due to time. Gradation rock influence the creep, which easily compactability. Gradation would have more creep. The comparison between dry and wet conditions cannot be concluded because of COVID-19 pandemic. The last one, this project can be used to evaluate the leaks before the construction state that occurred after the first use of the dam. For suggestion, the manual hydraulic pump should be controlled by automatic tools. Having automatic tools to collect the data for every second can make the obtained value more accurate. The tool to compact the rockfill material before test should be more appropriate to gain more accurate data. Thank you for your attention.